Okay, so what we're going to talk about in problem E is not so much a new strategy to deal with indeterminate limits, but something that can happen when you do a direct substitution that we don't know about right now. So let's look at this problem. So I have limit as x approaches 3 of x squared minus 9 over x minus 3 quantity squared. Now obviously I start with direct substitution, so when I plug 3 in, I get 9 minus 9, which is 0, over 3 minus 3, which is 0 squared, which is 0. So that's indeterminate, so that's going to send us on this chain. So I look at this and I see, okay, these are polynomials in top and bottom. I'm going to factor and cancel. The thing on the bottom is already factored. And the thing on top factors really easily. Now, there's my offending factor, the thing that's giving me 0 on top and bottom, x minus 3. Now, when I go back to do my direct substitution again, watch what happens. I plug in 3 on top, I get 3 plus 3, which is 6. I plug in 3 on bottom, I get 3 minus 3, which is 0. Okay, so when we were talking about the indeterminate form, we had 0 over 0. And 0 over 0 couldn't tell you anything about the limit because it depends on which thing on top or bottom is going to 0 faster. Now, when you have a number over 0, this is not indeterminate. I'm running out of room. The reason for that is if I think about numbers that are getting really, really close to 6 over numbers that are getting really, really close to 0, if I were to do like 5.9 over, say, 0.1, if I were to pop that in my calculator, that would give me 59. If I were to do 5.99 over 0.01, that would give me 599. 5.999 over 1,000th give me 5,999. If I were to keep going like this, as I get closer and closer to 0 on the bottom, my fraction is going to get larger and larger and larger. So this, when you get a number over 0 and it's approaching a number on top and 0 on the bottom, this is not indeterminate, this is infinite in some way. This is telling you that the y's are going to get super huge or super negative as I get closer and closer to that number. Now, remember, one of the things that we can say is that this limit is going to an infinity, but whenever you have a limit that's going to an infinity, that limit is non-existent, right? So since it's going to infinity, the limit would be non-existent. Now, we will talk about how to determine which infinity it goes to a little bit later on, and that'll be important in talking about vertical asymptotes. But for now, you can just know that means you have an infinite limit, and therefore the limit is non-existent.